All right, today we are doing section 1.1 in Algebra 1. And our central question is, how can you use simple equations to solve real-life problems? There's going to be a couple core concepts that you need to know before you do this. The first one is the addition property of equality. Adding the same number to each side of an equation produces an equivalent equation. What that really means is you want to add the same number to both sides of the equal sign. This applies for subtraction. The subtraction property of equality. Subtracting the same number from each side of an equation produces an equivalent equation. Pretty much you want to subtract the same amount from each side of the equation. For example, we know 4 plus, I'm not meant to put 4 equals 4. Let's go ahead and erase that. 4 equals 4. If I add a number to both sides of that equation, let's say 2, I'm going to get 6 equals 6. That's what the addition property of equality is. You're adding the same amount to both sides of the equal sign. So let's go ahead and work a couple of these out. We want to solve each equation, and then we are going to justify each step and check our answers. So we always want to start by writing the equation down. Here, what I notice right away is I have a minus 3. So I'm going to ask myself, what can I do to get rid of a minus 3? You do the opposite, which is plus 3. And if I do plus 3 on one side of the equal sign, I have to do plus 3 on the other side of the equal sign. And it might help you to visualize two sides of the equal sign by mentally, or if you need to, draw the line, putting a line through that equal sign, and then you should have plus 3 on one side of the equals, or on one side of that line, and plus 3 on the other side of that line. Those 3's cancel out. Negative 3, positive 3, they're opposites. They're going to cancel out. So I'm going to bring down my x, bring down my equal sign. Negative 5 plus 3 is negative 2. So my solution is x equals negative 2. Well, I want to check that. So I go back to the original equation and I write it down. And I'm asking myself, if I take out that x and I put in negative 2, is it going to equal the same thing? Well, negative 2 minus 3 is negative 5. Negative 5 does equal negative 5. That's my solution. Let's go ahead and do another one. This one's got some decimals in it. So first thing I do is I look and find out where my variable is. It's right there. And it looks like it's paired up with a plus 2.8. So I'm going to ask myself, well, what's the opposite of 2.8? Minus 2.8. So subtract 2.8 from both sides of the equal sign. 0.9 minus 2.8 is going to give you a negative number because you're taking away more than you have. Negative 1.9 equals y. So our solution is negative 1.9. We want to check that. Go back to your original equation, plug in the negative 1.9, and you get 0.9 equals 0.9. So we did that one correctly. All right, take a second. Try these out. See how you do. You might want to hit pause. Number 1, the answer is negative 10. You subtracted 3 from both sides of the equal sign. Number 2 is negative 1/3. You add 1/3 to each side of the equal sign. And number 3 is negative 10.4. You subtract 3.9 from each side. All right. This also applies to multiplication and division. The multiplication property of equality pretty much just says you have to multiply both sides by the same amount. The division property of equality pretty much says the same thing. You need to divide both sides by the same amount. Here, they're using the divisor sign. A lot of times in algebra now, we are not going to use that line with a dot above and below. A fraction bar is a lot of times what we're going to use. That means A divided by C. You might need to pause and write this down if you're taking notes. All right, let's go ahead and do our first example. I've got n, negative n divided by 5 equals negative 3. A lot of times I'll pair that negative sign up with the 5. And it's n divided by negative 5. I ask myself, well, what's the opposite of dividing? It's multiplying. So I'm going to multiply both sides by negative 5. And what happens are those 5s cancel out, and a negative times a negative is a positive. So I'm going to get n equals 15. You want to check yourself. You go back to the original problem, and you're going to put 15 in. 15 divided by negative 5 is negative 3. Now this one looks a little complicated, and the only reason this one looks complicated is because it's got that pi symbol on there. It's not a big deal. You're just going to divide both sides by pi, because it's pi times x, and the opposite of divide or multiplying is dividing, and those pi's then just cancel each other out. And you're going to get x equals negative 2. Plug that back in to check it. Go to your original equation, take out the x, put in negative 2, and you get negative 2 pi does equal negative 2 pi. And our last one, we've got some fractions. I've got 1.3z equals 5.2. Well, it's multiplying, so I ask myself, what's the opposite of multiplying? Dividing. So I'm going to divide both sides by 1.3. And if you notice, I use that fraction bar now to show division. And I get z equals 4. I want to write down my solution. A lot of times I'll just circle it, go back and check it, write the original problem down, take out the z, put in 4, 5.2 equals 5.2. All right, take a second, pause, try these 3 on your own, and I will put up the answers in just a second. The first one, you're going to multiply both sides by 3, you get negative 18. Number 5, you're going to divide by pi, and you're going to get 9. Number 6, you're going to divide both sides by 0.05, and you're going to get 28. All right. When you are solving a word problem, you want to understand the problem. What's going on? What's being asked? You're going to make a plan. How are you going to approach this problem? You're going to solve the problem. That just means you're going to carry out that plan. And you always want to look back and ask yourself, does that make sense? Is that a reasonable answer? Does that seem logical? You might want to take a second and pause, copy these down, and then we will approach a problem. All right. Take a second, read this, and we will write it down or solve it. So first thing we want to do is understand the problem. We know the winning time and the distance, and we're asked to find the average speed. So we're going to use our plan of the distance formula. Rate times time equals distance. That's one of those formulas where you're just going to be kind of expected to know that one. It's a really common formula. Oops. Looks like they wrote it as distance equals rate times time. It's the same thing. I did r times t equals distance. So plug in what you know. You know 200 is the distance. Rate is what we are looking for. And our time was 19.32. Divide both sides by 19.32. And we're rounding that to the nearest hundredth, so that's why they have the approximate sign. So his average speed was 10.35 meters per second. And you look back, does that make sense? Yeah. All right, try this one on your own. Take a second and pause it. Follow the same formula, and you should get 38.65. All right, when you approach a word problem, there's a couple different ways that you can go about doing them. Sometimes one way is better than another. These are all legitimate ways of doing it. I prefer writing an equation, using a verbal model, drawing a diagram. But depending on how your brain thinks, you might like some other methods. Again, you might want to pause and write some of these down. All right, let's go ahead and do another problem. January 22nd, 1943, the temperature in Spearfish, South Dakota fell from 54 degrees Fahrenheit at 9 a.m. to -4 degrees Fahrenheit at 9:27. How many degrees did the temperature fall? So, kind of figure out what's going on. At 9, it was 54. At 9:27, it was -4. All I'm picturing right now is that's a really big drop over a short amount of time. I'm going to use a verbal model to write an equation that represents, and then I'm going to solve. So the temperature at 9:27 equals the temperature at 9 minus the number of degrees the temperature fell. Well, and I'm going to let T be the number of degrees the temperature fell. That's called defining my variable. Putting in a variable and saying what it's going to represent. So -4 equals 54 minus T. I'm going to subtract 54 from both sides of that equal sign. And I get -58 equals -T, or T equals 58. So the temperature fell 58 degrees in approximately half an hour. A number line would have been another nice way of approaching this problem. -4 is the low temperature. 54 is the high temperature. There would be 58 spaces between the two of them. All right. Take a second and pause. Try this one on your own. The formula would have been 26 equals 68 minus C, and the answer is $42. All right. You should be able to describe in words how to solve a one-step equation. If that is difficult for you, you might want to come into Math Lab or iPass. And you should be able to solve that last equation by adding 4.3 to both sides of the equation. Enjoy.